First I would like to also help you with the pronunciation of the place where the church is situated.
I apologize, but
it's Kančevci, and I do not know. I understand that you don't know where it is, but I also doubt that many people here from Slovenia do not know where the Kančevci is. Well, it's eastern part of Slovenia, northeastern part of Slovenia. And today I'm going to present this topic. This is actually part of our national research project. And it was done by a couple of authors, Stilen Urbančić, who is actually the first presenter. Unfortunately, he was not able to come and attend this conference with us. So I'm the second one, my wife as a third, and assistant Petra Štokovnik and Božo Koller as the last one. So this is basically a mixed team of guys from geodesy and civil engineering. And actually here is the Kančevci, so you can see it's why it is important place. Well, it's a large spiritual center of Catholic Church, and it's situated nearby village named Selo. It has a very famous church named Rotunda. It was made by Templars in 14th century. This church is much younger, however, it's already third in a row on the same spot. The problems that challenges here were actually to evaluate the current state of the building, and then to perform some long-term monitoring, and then evaluate the causes of structural degradation, and then to make structural assessment and planning retrofit actions. When we are dealing with all those old buildings, we have to approach to them as a patient. So basically, we have to make to know their anamnesis, put diagnosis, prescribe therapy, and then to evaluate the controls. It's like with ordinary patients, but when we are talking about the buildings, we usually then have some methods that we make the building talk. So that means either we are focusing on material, on masonry as a material, or monitoring and control. Within that, our research project, we were dealing with evaluating a new sensor equipment for monitoring buildings, and so that is why we focused mainly on those non-destructive tests, so we performed also a bit of minor destructive tests. When it comes to the monitoring and control, there are different approaches. Either we are approaching from the point of the parameter we are investigating, point of the load, and or are we performing periodic or permanent monitoring. Of course, for that building that we had to deal with, permanent monitoring was not possible, so we had to perform it in periodic way. And we were called to that site once bigger cracking started to occur. We established the procedure that we have to follow through our investigation. So we were focusing on next. On architectural and structural identification, geometrical survey by measuring and 3D laser scanning, crack pattern investigation, geodetic methods, geodetic networking, leveling, terrestrial laser scanning, vibration test, ground penetration radar investigation, and then monitoring of classical civil engineering approach, that is, you monitor the development of cracks, but this time we also did it with comparing those results with the multiply 3D laser scanning results. Nevertheless, we also perform some profile of moistures, etc., and sampling of materials, but I'm not going to present it here in this presentation. Unlike that previous church in Assisi, well, this is a very young one. This is actually only 120 years old. It's actually third in a row. First was Benedictines, then it was Protestant, then it was Catholic, so everyone wanted to have each of its own. Bell Tower is probably from the 17th century. Otherwise, the church is made from the perfect brickwork, old Austro-Hungarian normal format with very good lime mortar. Unfortunately, the foundations are very bad, actually, and that is one of the main reasons why we had those problems with this structure. But I'll show it later. The major problem began here. In 1996, there were some large excavation works within the nave, and the foundations were completely opened. At some points, they were even undermined for some 20 centimeters, and they stood like that for 3 years. So during that time, the structure started to crack, and then they closed that. I'll show it later. But then extensive cracking actually began later in oh gee, what I'm doing, and later in 2016. So problems. Church is severely cracked. Other thought was maybe this tree could have some problem. I mean, some influence on the cracking of this wall. Soil is a soft clay, and we know it has a problem when you got moisture. It expands and it shrinks during the summer. DPC, damp-proof course, was built within the nave, but not beneath the bell. So in the bell we had problems with salt. From the outside, everything looks perfectly well, except for some old cracks in this north wall. On the other hand, the major problems are here within the nave. So within the choir, we have cracks here, and also the vault and the arches of the nave are severely cracked. Those cracks are at some points even up to 2 centimeters big. So the architecture is fairly simple: single one bay, bell, aisle, sacristy. I don't want to comment because it's a newer one. Here is maybe a trick a bit, because the tie is put on the top over the arch, so it does not prevent this outward thrust. So it just helps to maintain those walls on a place because of the roof structure. The thickness of the arch is 60 centimeters. That means 2 normal format of the Austro-Hungarian brick, and at the top it's only half of the brick thick. So this is one of the, I think, major problems are those walls, are those foundations. You can see it's a brickwork, it's rubble brickwork without lime mortar, probably washed, and while those guys from archaeology they dig something 1 meter deep, and they undermine those foundations. On the roof, possible problem could be also this position of that wood element, because it should be beneath here. Now it's hanging in the air. So there are a couple of things that may also influence the crack propagation. This is the overview how it looks for 3 years, after this excavation, they found out also that this part of the church is lying on some old tower, and this part of the church is lying on some old chapel. Colleagues from Geodetic, they perform first measurements. First, they thought that they would be well with three known points, but then they later extended on additional 2. They figure out that all points are stable. Then they perform also the network for the TLS measurements. Vertical displacements, first measurements were performed in November 2017, and the second one in May 2018. And it turned out that after the long dry period of time, the soil was very shrinked. So when it got enough of the moisture, it swelled a bit. So that is why they got a bit of uplift. Of course, you cannot say to the priest that your church is going to up. You know, so we waited for additional time to see. So the long term, actually, this north wall is going down, but you can see it's going just this part of the wall. These are fairly stable. Then the laser scans were performed, and we used them for identifying the geometry as well to identify the major cracks. That is very good tool. So whenever you have large cracks, do it that way because it's much more accurate than take it in pen in your hand and then start right. From here, we went further and we actually draw our own. These cracks here are new one. These are actually the old one. You can see it on the spot. And also, what is very important, the bell is completely almost separated from the main nave during these cracks. The out-of-plane deformation with 3D laser scanning showed that also there are some large changes from two different measurements. Also, laser scanning helping us to find out what is out of plumb, and north wall is obviously leaning out. The major reason is because of the settlement of the choir here that was due to this excavation. So that is why we have these cracks that are actually pushing this pillar outward. Here is also attempt to compare two different laser scanning results, but then again, those results are within the accuracy of the laser scanning. Within the nave, we try to get something more efficient with the laser scanning, but unfortunately, due to shadows of the either organs on the choir or the chandeliers, you cannot actually get some good presentation. Also, here is a problematic the projection of the results on the surface. Traditional measuring was measuring deformation along across the cracks at different position. On the vault here on the choir, connection between the main nave and the bell tower. And what we got, and that was when we were a bit in panic. After 4 months, we got 5 mil of crack propagation. That means if it would go like that, by the end of the year, you can get 1 centimeter, or that would actually mean that we should close the church. Fortunately, it stopped at some point, so now we have time to plan retrofitting works. For the purpose of numerical modeling, we also performed the vibration tests with accelerometers at different positions. All of you who are familiar with the vibration tests know that there is plenty of things to be filtered. Here are actually the bell rings. What we are looking is basically this part here, and here are the results for the main nave. Here are the results for the bell. All these results actually will be checked through the numerical modeling later on that will come. And the last test that we performed was a ground penetration radar test. Here we actually tested the new multi-purpose GPR antenna that can actually be adjusted from the 50 megahertz up to a couple of gigahertz. It's just a couple of kilos. It's very well handleable. So any one of you who is thinking to buy a new GPR, wait, a new thing will come on the market. It's easy to be used, and we actually figure out what we could not get from the documentation, because when they closed in '99 this church, we didn't know if they put any reinforced concrete beam along here. With the radar, we could easily find out the rebars, which are actually in radiogram here much more apparent. So the effective numerical model is going to be definitely some finite element modeling with homogenization approach combined with the macro block modeling, because this is the only way how you can model the churches. And conclusions. So combination of the geodetic and civil engineering methods are efficient and highly recommendable, especially when you on long distance from the, for example, ceiling, etc., and you have to perform some crack patterns, and also to figure out what is the main cause of the degradation. Still, what we have to do is geomechanical investigation, preparing a numerical model, and then design retrofitting actions. Thank you. I hope I was in time.